Ferrari has just dropped a shocking revelation from Abu Dhabi 2025, secretly testing a 2026 upgrade that could change the entire F1 landscape. The mule car showcased a revolutionary double pushrod suspension and advanced active aerodynamics, signaling Ferrari's aggressive strategy to leap ahead before the season even begins. The twist: Charles Leclerc and Lewis Hamilton were behind the wheel, pushing the car to its absolute limits while generating critical data that could dictate Ferrari's 2026 championship approach. And the fallout: rival teams are scrambling to understand the potential performance gains, debating if Ferrari's bold gamble will give them a decisive edge or create unexpected problems. Subscribe now, you don't want to miss a single explosive update, as Ferrari's 2026 project could redefine the entire Formula One hierarchy. The Abu Dhabi post-season testing took an unexpected turn when Ferrari revealed it had been secretly testing a hidden 2026 upgrade. The mule car incorporated revolutionary components, including a double pushrod suspension system and advanced active aerodynamics, signaling the team's intent to gain a technological edge before the official pre-season testing. The secrecy of the program left rival teams scrambling to analyze the implications and anticipate potential rule compliance issues. Telemetry from the test runs provided Ferrari with a wealth of data. Engineers meticulously recorded steering inputs, throttle applications, suspension travel, and aerodynamic responses at various speeds. This allowed them to understand how the new components affected car balance, cornering efficiency, and overall lap performance. The insights gained from telemetry were instrumental in fine-tuning the new systems for both performance and reliability under racing conditions. The involvement of drivers Charles Leclerc and Lewis Hamilton added a crucial layer to the testing program. Both drivers were asked to push the mule car to its limits, simulating aggressive cornering, braking, and acceleration scenarios. Their feedback on handling, responsiveness, and overall car balance allowed engineers to correlate subjective impressions with objective telemetry, refining component performance in real time. High-speed video captured every nuance of the mule car's behavior. Frame-by-frame analysis revealed how the new suspension absorbed curb impacts while maintaining tire contact and aerodynamic stability. The data also demonstrated how the front wing adjustments contributed to consistent downforce through high-speed corners. This integration of video and telemetry ensured that Ferrari could validate theoretical performance gains against real-world behavior. Mechanical simulations were conducted in parallel to the on-track tests. Using the telemetry data, engineers simulated tire loading, aerodynamic flow, and suspension dynamics under extreme track conditions. These simulations allowed the team to predict component behavior across different circuits and temperatures, ensuring that the 2026 upgrade would be effective and reliable throughout the season. The broader paddock reaction was immediate. Rival teams, analysts, and engineers scrutinized leaks and images from the test to try to reverse engineer Ferrari's approach. Discussions erupted about whether the secretive nature of the program could provide Ferrari with a decisive advantage, or if regulatory constraints would limit the component's effectiveness in actual races. The test underscored the competitive intensity of pre-season development and strategic planning in modern F1. Finally, the Abu Dhabi test highlighted the evolving nature of Formula One innovation. Ferrari's ability to integrate cutting-edge suspension and aerodynamic technology, combine it with real-time driver feedback, and collect precise telemetry demonstrates how technical mastery can redefine the competitive landscape before the season even begins. The revelations from this secret program may set the tone for the 2026 championship, illustrating how ingenuity and calculated risk are central to achieving F1's supremacy. Ferrari's secret testing program in Abu Dhabi provided engineers with a treasure trove of real-world data. Every sensor on the mule car captured telemetry on suspension travel, ride height, tire load, and aerodynamic performance. This data allowed Ferrari to see exactly how the new components behave under extreme racing conditions, offering insights into both stability and lap time potential. By combining this information with theoretical models, the team could predict performance improvements with a high degree of accuracy. Mechanical simulations complemented the on-track data, allowing engineers to test the limits of the new components without risking damage to the mule car. The simulations analyzed stress distribution in the double pushrod suspension and the effects of the advanced front wing on airflow and downforce. These virtual tests enabled Ferrari to identify potential weak points and optimize the design before committing to full-scale production for the 2026 car. High-speed video captured the mule car in action from multiple angles. Frame-by-frame analysis confirmed the telemetry readings, showing how the suspension absorbed curb impacts while maintaining optimal tire contact. The video also demonstrated how the active aero components adjusted dynamically to maximize downforce and minimize drag. This cross-verification ensured that the data was both accurate and actionable. Driver feedback added a crucial layer of subjective data. Charles Leclerc and Lewis Hamilton provided real-time observations on steering response, car balance, and cornering feel. Their input was essential for engineers to correlate the numerical data with the human perception of handling, enabling fine-tuning that could only be achieved with experienced F1 drivers behind the wheel. Environmental conditions were carefully recorded throughout the testing sessions. Factors such as track temperature, wind, and humidity were monitored to understand how they influenced the new component's performance. This allowed Ferrari to adjust simulations and predict how the car would behave across different circuits and weather conditions in the 2026 season. The integration of telemetry, simulations, high-speed video, and driver input created a comprehensive dataset that provided a holistic view of the new component's performance. Engineers could identify lap time gains, improvements in cornering stability, and potential areas of concern. This multifaceted approach gave Ferrari a clear advantage in refining the car before rivals could even begin pre-season testing. Finally, the paddock's reaction to Ferrari's secret program was intense. Rival teams analyzed leaks, telemetry insights, and images from the Abu Dhabi tests, trying to understand the potential performance edge. Analysts debated whether Ferrari's early development gamble would translate into a decisive advantage in 2026 or face limitations due to regulatory constraints. The secret testing program showcased how innovation, data, and strategic foresight are central to maintaining a competitive edge in Formula One. In modern Formula One, even a minor technical innovation can produce significant lap time gains. Ferrari's secret Abu Dhabi tests provided engineers with a highly detailed dataset on the 2026 mule car, revealing how the new double pushrod suspension and active aero components interacted with the car's chassis and tires. Every sensor captured variations in ride height, suspension travel, and downforce, providing a precise understanding of how these systems would affect performance under extreme racing conditions. Telemetry analysis revealed that the double pushrod suspension improved tire load distribution during high-speed cornering, maintaining optimal grip and reducing energy loss. Engineers could measure how suspension compliance influenced the car's balance, allowing the vehicle to maintain speed through challenging corners. The data confirmed that the system produced a measurable advantage in handling and stability, potentially translating into valuable lap time improvements. Mechanical simulations complemented the on-track data. Using computational fluid dynamics and structural analysis, engineers predicted how the active front wing and suspension interacted under different speeds and track conditions. Simulations showed that minor adjustments in wing angle or suspension geometry could significantly affect aerodynamic efficiency and tire contact. This allowed Ferrari to optimize the components for maximum performance while minimizing risk of failure. High-speed video analysis added visual verification of telemetry readings. Cameras captured the car's behavior during aggressive cornering and curb impacts, showing how the suspension absorbed shocks and maintained aerodynamic stability. Frame-by-frame examination confirmed that the theoretical performance gains from simulations matched real-world behavior, validating both the mechanical and aerodynamic improvements. Driver feedback provided another critical layer of insight. Charles Leclerc and Lewis Hamilton evaluated steering response, balance, and overall handling. Their observations allowed engineers to correlate subjective sensations with quantitative data, ensuring that improvements were not only measurable but also practical for race conditions. This combination of human perception and telemetry data is essential in refining components for maximum competitive advantage. Environmental factors were meticulously monitored throughout testing. Track temperature, wind speed, and humidity were recorded to evaluate how the new components would perform in varying conditions. Engineers used this data to predict performance consistency across multiple circuits, ensuring that the 2026 upgrade would be both effective and reliable throughout the season, regardless of track or weather variations. Finally, the technical implications of Ferrari's secret testing are substantial. By integrating telemetry, simulations, video analysis, and driver feedback, Ferrari gained a holistic understanding of how the new components enhance performance. This multi-layered approach positions the team to enter the 2026 season with a potentially decisive advantage, demonstrating how secrecy, innovation, and precise engineering can redefine competitive dynamics in Formula One.